Hey everyone, welcome back to the last set of tests for convergence. We've got alternating series and ratio test. This is section 8.5 and section 8.6 in your textbook, but they're pretty short, so I'll put them together. Alternating series test. This is what happens when things bounce back and forth between positive and negative. Now what gives it away that something's bouncing between positive and negative? You get -1 to a power, because all that does is just alternate the signs. Okay? It converges if the nth term goes to 0, so the nth term test is inconclusive, and if the next term is less than the previous term for all the terms. So let's take an example here. This is an alternating series. You can rewrite this like this. You can pull the -1, the alternating part out, put -1 to the n, and then it's just 1 over 2 to the n. This is a geometric series, so we're pretty sure it's going to converge. Let's test it. If you go to infinity, do you get 0? Yep, 1 over infinity is 0. Is the next term always smaller than the previous term? Well, look at these. Ignore the positive and negative. Is the next term always smaller than the previous term? Is the next term always smaller than the previous term? Yes. Since both of these are true, it's convergent. A lot of alternating series converge. Let's take a look at this one. This diverges. 1 over n is harmonic series, and it diverges. But it's alternating, so we have to check it. If you need to write it out, let's write it out. This would be -1 plus 1/2 minus 1/3 plus 1/4, and keeps going. Does the limit go to 0? What's 1 over infinity? It's 0. That one works. Is the next term always less than the previous term? Ignore the alternating. Is the next term always less than the previous term? Yep. So, this is convergent. Even though a harmonic series is divergent, by making it alternate, it becomes convergent. So that's the alternating series test. If it's alternating, you only have 2 questions to ask. Does it go to 0 as you go to infinity? And is the next term always less than the previous term? If the answer to both of those is yes, it's convergent. Note, just because it fails the alternating series test does not make it divergent. We can't say anything. Alternating series test either says yes, it's convergent, or we don't know anything. So keep that in mind. Ratio test, the last test and the most complicated test. If you have positive terms, let's take the limit as you go to infinity. I'm going to put n plus 1n for n on top, and I'm going to leave the bottom the same. Whatever that number is, if that number is less than 1, it converges. If it's greater than 1, it diverges. This is great. It's a test that not only tells us whether it converges or diverges, but it never fails. Oh wait, yeah it does. It fails if L is 1. So if the limit is less than 1, it's convergent. If the limit is greater than 1, it's divergent. If it's 1, it fails. You don't know. So let's take an example of one. Okay? Let's do this one. We know this is divergent, so let's prove it with the ratio test. The ratio test says do n plus 1 on top, so 1 over n plus 1, 1 over n, the regular function on the bottom. That, dividing by 1 over n is the same as multiplying by n, but that's 1. That's inconclusive. So even though we know this is divergent, we can't prove it with the ratio test. What about if I try 1 over n squared? Well, that we know is convergent because it's a p-series, but if I do the ratio test, I get 1. I can't prove this with the ratio test. So the ratio test doesn't work here either. So when would I use the ratio test? We use it for series that converge rapidly. Factorials and exponentials. So let's talk about factorials and exponentials a little bit. Take a look at this. N factorial means n times n minus 1 times n minus 2 times n minus 3. This means the same thing, except it's got one more term. So these two are the same thing, except n plus 1 is an extra term here. So all the other terms will cancel out, and you get n plus 1. To show you that as an example, suppose you had 5 factorial over 6 factorial. The bottom one is one more than the top one. This is 5 times 4 times 3 times 2 times 1. This is 6 times 5 times 4 times 3 times 2 times 1. And all of those will cancel out with, and you're left with the bottom. How about exponentials? Well, n plus 2 to the n plus 1 over 2 to the n. When you multiply, you're adding exponents. So adding exponents means multiply. These will cancel out, and you're left with whatever that power, whatever that addition is at the end. So that's important for what we're about to do. Here's an example of something where we need to use the ratio test. These are enormous functions. Exponentials and factorials are enormous functions. So let's do the limit. As n goes to infinity. The ratio test says put plus 1 in for all your n's. Divide that by your original function. Rewrite that as a multiplication problem. Now let's look at these two together and then the other two together. We just talked a second ago, 2 to the n plus 1 over 2 to the n is 2. N over n plus 1 factorial is 1 over n plus 1. Plug in infinity, and you'd have 2 times 1 over infinity is 0. You'd have 0. Now, which of the three cases is it? The three tests for ratio test, less than 1, greater than 1, equal to 1. This is less than 1. What does less than 1 mean? It's convergent. There's a ratio test that works because we dealt with enormous functions. Let's try this one. That's the limit. As n goes to infinity. So this is going to be n plus 1 squared. 2, n plus 1 is n plus 2, 3 to the n plus 1, divided by the original function. Okay? Let's rewrite that as a multiplication problem. N plus 1 squared over 2 to the n plus 2, 3 to the n plus 1. Flip the bottom, makes that 3 to the n. N squared, 2 to the n plus 1. Okay? Now let's start canceling some things out. Let's look at my just n's. These won't cancel out. That's n plus 1 over n squared. Let's look at the 3's. 3 to the n over 3 to the n plus 1 is 3 on bottom. Sorry, it's 1/3. Let's look at the 2's. The 2 to the n's will cancel out. So I have a 2 to the second on top, a 2 to the first on bottom. I get a 2. So let's multiply all that together. That's the limit as n goes to infinity of n plus 1 over n squared times 2/3. Now let's plug in what I know. If you plug in infinity here, this is same over same. So I'll look at the numbers in front, and the numbers in front are 1 times 2/3. 1 times 2/3 is 2/3. That's less than 1. This thing is convergent. Ratio test. N plus 1 on top over n on the bottom, infinite limit, If you get a number less than 1, it's convergent. If it's greater than 1, it's divergent. If it's equal to 1, the test fails. And that does it for all the convergence testings. You have to memorize all the tests, and you have to know them. Really, really know them for the test and for the AP test. Know what they say. Know what they don't say. Good luck.